Hi everybody, in this video I want to tell you a bit about the vertex form for a parabola or a quadratic polynomial, a degree 2 polynomial. We saw in the last video that you could represent a quadratic polynomial in this form where we have x minus something, the whole quantity squared, times a plus a constant term. And this was called the vertex form. Now I'm going to tell you why. Well, if our expression is written in this way, instead of in the standard form like this, then the vertex of the parabola is given by h comma k. Now, why is this true? We're going to do an exploration of this in class, but the basic idea is that the parent function is x squared. This looks kind of like the expression y equals x squared. But then I changed x by switching x to x minus h. So it's shifted to the right by h. And then I added on k, so it's shifted up by k. And then I did a stretch or a shrink by a. So the reason that hk is the vertex is that if we look at the graph of x squared, its vertex is at 0, 0. And then if I go up by h and over by k, then I get x squared shifted, and the new vertex is at h comma k. And I could stretch or shrink it, but the vertex itself is not going to change. So the a doesn't affect where the vertex is. So that's why the vertex form is so useful. If I'm given an expression like this, and I complete the square to put it in vertex form, I know immediately what the vertex is. In later videos, we'll be graphing quadratic polynomials, and putting it in vertex form is the best way to get started because it tells you immediately what one of the points on your parabola should be. So let's do a quick example. What's the vertex of f of x equals x minus 4 quantity squared plus 3? So in this case, h is 4 and k is 3. So the vertex is 4 comma 3. So that's easy, right? And you could think about it again. This parent function is x squared. I did a shift to the right by 4 and a shift up by 3, so I moved the vertex from 0, 0 to 4, 3. Vertex form's really easy to understand. So there's also a formula in order to figure out the vertex if it's written in standard form, and I will give you 5 extra credit points if you prove this to me. So 5 extra credit points if you show me a proof. So let me just tell you what the formula is based on these coefficients. So the vertex in this case is going to be negative b over 2a. That will give you the x coordinate of the vertex. To get the y coordinate of the vertex, you just plug that in to f. So you do a, and then instead of x, you'd put negative b over 2a squared plus b times negative b over 2a plus c. And whatever that turns out to be, that gives you your y coordinate. So let's do another example so I can convince you that this formula actually works. We want to know what is the vertex of x squared minus 2x plus 2. So I can use the formula so negative b over 2a is going to be negative, negative 2, because b is negative 2, over 2 times 1. So what does this end up being? 2 over 2, which is just 1. Then f of negative b over 2a is just f of 1. I plug this in, and so I get 1 squared minus 2 times 1 plus 2, and that ends up being 1. So this tells me the x coordinate This tells me the y coordinate. So together, that tells me the vertex is 1, 1. I could figure it out by putting it first into vertex form as well. So the vertex form of this equation, I need to complete the square. So I have x squared minus 2x. I'm going to add something, and I'm going to subtract that same thing, and then I have the plus 2 left over. So to figure out what to add, I divide this term by 2, that's negative 1, and I square it, so that's 1. So then I need to subtract 1. This is now a perfect square. It's x minus 1 squared, and then I have minus 1 plus 2 is plus 1. So this is the vertex form. So my h is 1, my k is 1, so that tells me the vertex is 1, 1. Okay, so that's the basics of vertex form. It's really pretty easy. So try to do some of the examples in the web work. If you get stuck, there are going to be 2 more videos coming. So watch those as well, and they'll help you do the more complicated problems. But these are the basics. Great job!